Hi everyone. Our lesson for today is solution of homogeneous differential equation. So we're going to study the determination of complementary function. Let's begin with linear differential equation with constant coefficients. A linear differential equation with constant coefficients is that in which the dependent variable and its differential coefficients occur only in the first degree and are not multiplied together. This is the standard form, where a sub 0, a sub 1, a sub 2, up to a sub n are constants. And capital X, this is the capital X on the right side, is a function of x, or a constant. We have here two examples. Example 1, the second derivative of y with respect to x plus the first derivative, that is dy over dx, minus 6y equals 0. Second example, second derivative of y with respect to x minus 3 times the first derivative dy over dx plus 2y equals e raised to 3x. Let us study operators. The part d over dx of the symbol dy over dx may be regarded as an operator, such that when it is operated on y, the result is the derivative of y. In symbolic form, we write d over dx equals capital D. For d square over dx square equals d square. For the d raised to n all over dx raised to n is equal to the capital D raised to n. Then, the standard equation given here, that is regarded as equation 1, can be rewritten as like this. And on the left side, we can see that a common factor of variable y is observed. So we can factor it out, and we can rewrite this equation into like this. This is now equation 2. For example, express second derivative of y with respect to x plus first derivative dy over dx minus 6y equals 0 with corresponding operators. So this will be the answer. The quantity d square plus d minus 6, and then this is multiplied by the variable y equals 0. Now, the solution of homogeneous differential equation. In the standard form that is written here, when x equals 0, meaning the right side becomes 0, we can write again this equation into like this. And the general solution now is y equals complementary function. And we write capital C, capital F to make it short. Let us determine complementary function. Using operators, the standard equation is written here. Well, we see that the right side is 0, becomes this equation when we use the operators, that is the capital D, respectively. Suppose y is equal to e raised to mx is a trial solution of this equation. Then we have this new equation, whereas the capital D is changed into m, and this y here is changed into e raised to mx. But we say that this e raised to mx is not equal to 0. Therefore, this equation inside the grouping symbol, we can put it out equals 0. And this equation now is known as auxiliary equation. We have capital A, capital E for short. Take note that when we replace capital D by small m, then the above equation is called AE, or auxiliary equation. Based on the nature of the roots of the auxiliary equation, complementary function is derived as listed. Suppose we have two real and different roots. This is now the corresponding complementary function. C sub 1 times e raised to m sub 1 times x plus c sub 2 times e raised to the power m sub 2 times x. What about for three real and different roots? We have this c sub 1 times e raised to the product m sub 1 x plus c sub 2 times e raised to the product m sub 2 x plus c sub 3 times e raised to the product m sub 3 x. What about for two real and equal roots, meaning the values are equal? So we have this complementary function. We have the quantity c sub 1 plus c sub 2 times x, and then multiplied to e raised to the product m sub 1 times x. For three real and equal roots, we have this complementary function. The quantity c sub 1 plus c sub 2 times x plus c sub 3 times x squared to be multiplied to e raised to m sub 1 times x. Sometimes there is one pair of complex roots, and that is alpha plus or minus I times beta. The complementary function will be e raised to alpha times x to be multiplied to the quantity c sub 1 times cosine of beta times x plus c sub 2 times sine of beta times x. Sometimes the roots are one pair of complex roots and one pair of real and distinct roots, meaning this is a combination of this and the first line. So we will just put them together. Example 1. Solve the equation. Second derivative of y with respect to x plus the first derivative dy over dx minus 6y equals 0. We're going to use operators, and to rewrite the equation, it becomes like this. The quantity d squared plus d minus 6 to be multiplied with the variable y equals 0. Then we write the auxiliary equation. We change the d into m. So we have this m squared plus m minus 6 equals 0. Then let us find the roots. Let us solve the equation. Let us use the factoring method. So we have this m minus 2 times m plus 3 equals 0. We equate each factor into 0. We have now this m minus 2 equals 0 and m plus 3 equals 0. Solving for m, we have m sub 1 equals 2 and m sub 2 equals negative 3. We can see that we have here two real numbers and different roots. Now we solve for the general solution, and this is y equals complementary function. Based on our table a while ago, the complementary function will be like this. Then we substitute the values of m sub 1 and m sub 2 respectively. So our answer is y equals c sub 1 times e raised to 2x plus c sub 2 times e raised to negative 3x. Example 2, solve the equation second derivative of y with respect to x minus 9y equals 0. Let us use the operators and rewrite the equation. So we have the quantity d squared minus 9 multiplied by variable y equals 0. So for this d squared minus 9, we are going to write the auxiliary equation. So we have m squared minus 9 equals 0. Let us find the roots by doing factoring. So we have this m minus 3 times m plus 3 equals 0. We equate each factors into 0. So we have m minus 3 equals 0 and m plus 3 equals 0. Therefore, m sub 1 equals 3, positive, and m sub 2 equals negative 3. So we have here two real and different roots. For the general solution, we write y equals complementary function. Based on our table a while ago, we have this equation. And then we're going to substitute the values of m sub 1 and m sub 2 respectively. So we have the final answer. Y equals c sub 1 times e raised to 3x plus c sub 2 times e raised to negative 3x. Example 3. Solve the equation. Third derivative of y with respect to x minus second derivative of y with respect to x plus first derivative dy over dx minus y equals 0. Using our operators, we can write the equation into like this: d cubed minus d squared plus d minus 1, and the whole quantity is multiplied by y equals 0. Then we write the auxiliary equation. We have this m cubed minus m squared plus m minus 1 equals 0. Let us now find the roots. We will use substitution method. Let us group the first two terms and let us group the last two. In the first group, there is a common factor, and that is m squared. We can factor it out. And we have now these two big groups with a common factor, that is m minus 1. We can pull it out and we have like this m squared plus 1 multiplied by m minus 1. Then we equate each factor into 0. So we have m squared plus 1 equals 0 and m minus 1 equals 0. Simplifying further, we have this m squared equals negative 1 and m equals 1. So we have here one value of m. On the first factor, we have this m equals plus or minus the square root of negative 1. And we can simplify this further into plus or minus I. So it means in here, we have three answers. We have three roots. So it means we have here one real and one pair of complex roots, alpha plus or minus beta times I. For the general solution, we write here y equals complementary function. So we combine the one real, this is the solution, plus the one pair of complex roots, and this is our equation. For the m sub 1, we're going to take the value of 1, and for the complex roots, take note that alpha is equal to 0 and beta equals 1. Substituting the values in the equation, it becomes like this. Now take note of this e raised to 0 times x. The 0 times x becomes 0, and the e raised to 0 becomes 1. It means we can simplify further the final answer into like this: y equals c sub 1 times e raised to x plus c sub 2 times cosine of x plus c sub 3 times sine of x. I hope you learned something from this video. See you again next time.